Have you done it? So please let me know. Yeah, I'm talking about the last class only. Yeah, I'm talking about the last class only. So sir has given there was two cylinder, 20 mm apart from each other. Okay. So that was just for a practice, and all the recorded lectures for this particular CFD is available in our YouTube channel. You can refer them. And there are some video which I have also mailed, and there are some other video our team has mailed you. So you can refer that. Here, this is a very important thing to understand the boundary conditions, how the things are work. Okay. Okay. Srinivas, are you ready with your design or the analysis that you have done? I think we need some more time. And meanwhile, sir will be joining with us shortly. Okay, what about Evans and other student? Evans, have you done it? Okay, fine. Take your time.
No,
Yes. Yes,
I
Evans.
sent you. I sent you an email, but you haven't yet responded.
No, have you done, sir? Has given some task to you, right?
I did a different one, but I need
Okay.
recommendation. So
Can you just show the things that you have done it?
sorry.
Can you show the things that you have done it? Whatever the analysis
Yeah,
Bob have asked,
yeah,
can you show it?
yeah. I can show. The problem I was having is like to interpret what has been done.
What you have? Did you face any difficulty?
I was
Did you face
following.
any?
I was following it like a certain YouTube video. So it was an airfoil in 2D, and then
Okay.
I finished. I got a video. I produced a video and like a picture, a
Okay.
graph of all lift coefficients. And then there are other things I didn't understand. So I wanted to ask much about such kind because the video it didn't
Okay,
finish
Yvonne.
until
Yeah,
you let us.
listen. See, airfall is great that you have done, but have you done it like two cylinder keeping apart, and how you have included the meshing? The main thing is a challenge in, and how you have given the count of the machine. What are the boundary layers? How you have implemented the boundary layer? That's the main challenge over here, right? Have you tried that in before going into the airfoil? Because airfoil is really complicated. So first get accustomed with the cylinders, then you can move to the other things. That's the thing. Okay. So first, you have done the airfoil is good, but cylinders. So you will get no hands-on. You will get a strong hands-on activity with this Ansys and other machine thing. So things will be easier for you, right? That's a motto. Okay. Uday, have you done it? Uday, then who is left? Marty, Marty. Have you tried on the CFD? So in Saturday session, we will assign you a particular, the project. So in a week, you have to complete that project, right? And submit the analysis with us, right? So please, before that, please do practice it. Please do practice it. Okay. So you will get accustomed, and tomorrow you will have one more session that how to write up a paper, how you can jot down the things that you're going to work on, right? And so be prepared for that. All right. So just wait for 2 minutes. Sir will be joining with us shortly. Meanwhile, if you are ready with your design, you can share with me. Hello, good evening, Jenny. Hello.
Hello, ma'am.
Yeah, good evening.
Good evening, ma'am. Good evening.
Yeah, good evening. Yeah.
So, ma'am, today we will I will teach some this airfoil analysis.
Okay, great. Yeah.
Ah,
Actually, today one of the student has tried, but he couldn't able to do it.
okay.
So you can guide them, right?
Okay, ma'am. They have some files means I can instruct them, or else shall I start from beginning?
Yeah. Actually, only one student only has done it. So you just focus on your part. So if he is having any issues, he will contact you. Okay.
Hmm. Okay, okay,
Okay.
ma'am. Okay. So, this opening the interface and all last class itself we have discussed. So for this class, I will just I already opened.
Yeah.
So
Uh,
in that
Jimmy,
geometry,
one more thing. One more
yes.
thing. The students are facing certain issues like
Mm,
problem with the software. Like sometimes
okay.
it is opening and sometimes mesh is not is getting saved. They have to start from the very start, right? So do you have any particular solutions for that?
In which area they are getting like trouble means then I can help ma'am. In mesh or in opening the software itself.
Yeah, both
Okay.
as of. So, student, if you have any particular issues, please unmute and just discuss with Dr. Jeannie, sir. Okay.
They can put
Yeah.
their queries either in chat box or there they can
Yeah.
discuss.
Yeah. Yeah. Right. Okay. Meanwhile, you just start and they will put up the
Okay.
questions. Okay. Carry on.
So I just opened the interface of geometry in that in designer modeler, and first of all, with before doing the analysis, we need to set the plane. So I'm setting the plane, XY plane. I'm doing, and here.
Jimmy is not visible actually.
Oh, sorry, ma'am. Sorry, sorry.
Okay, no problem.
Okay, here it is not. Now it is visible, ma'am.
Yes, it's visible. Yeah.
Okay, okay, fine. So this will be our workbench, and we started that designer modeler. So in designer modeler, first of all, the primary thing is to set the plane. So I set the plane now. Now to do airfoil analysis, we should be very clear. Like we need to have an airfoil that either you can draw here. If you have the coordinates, you can import manually through the create points or else directly there is one option for importing the airfoil. So like two ways we can do. I'll show how to do that. Finally the format should be in this way. So this first one is the group, which group that airfoil. This is the first airfoil we will be importing, so the group will be named as one. Second will be the points, how many points the airfoil have. Third will be the xy coordinates, so xy and z coordinates. So this is the format. So to do this one, first of all we should go to this airfoil tools. So in airfoil tools, or else suppose if you want to do like this means also 0012 airfoil. If you type in airfoil tools only, it will come straight away. You can go there and you can get the csv file, or else see here naka 4-digit generator is there. In this if I want to do 0012 airfoil mean here maximum camber is 0, maximum camber position is 0, and this will be like. And if I want to increase the points also, I can increase, or else let it be the same points also. Thing is like if you want to close the trailing edge, here you have to give check this one, so that the trailing edge will be closed, and you just give plot, so it will be plotted. After that send to airfoil plotter, so you'll get like this. Here if you want to change the card means you can change the card here. If I'm giving like 1 meter card means it will be set in 1 meter card. Then again you give plot if anything is changed means, otherwise let it be. Give like a csv file for coordinates. So csv file will be opened, downloaded, and you can open that one. So once it is opened, you will get the xy coordinates like this. So here I'm just copying this one, and I'm just opening the new sheet. Here I'm pasting this. Can give here group. Second one is the points, x coordinate. Z coordinate here. Then same way here you can give one. Okay. So this is how we should create the points. Once it is created, just copy everything, paste here, give save as 0012. It is saved. Now come to designer modeler. Here create points is there. Two options is there. One is concept, but in this concept 3D curve, sometimes it will work, sometimes it will create some issues. Sometimes so better is to uh, one second. Okay, let it be. We'll do in the other way. Sometimes this 3D curve that will not work. It will show some errors. So better you can import by points only. Here in points, you just manual import you can do by coordinate file. Select the coordinate, give open, it will be opened. Okay. Now we got the airfoil. Now, if you want to, first of all, what we need to do is we need to connect a line over this airfoil. So here, line from points is there. Select that line from points. We can start from here. This will be the better one. So right click and give point chains and connect all points. For CFD analysis, it will take some time. You have to be very patient only. Give apply and give generator. Sorry. Oh, I deleted the last one. Okay. It is not. So after creating this line in concept, surface from edges, here you can select the edges, and give apply. So the surface is created. Once that surface is created, next is to design the control volume. So for designing the control volume, just give sketching in that. So draw a horizontal line. I'm just making one C type control volume. So for making C type control volume, so here the total card is like one. Can measure it. So 42 meter. So it is card is 1,900. You can when I'm giving 10, okay. So our control volume should be like 10 times the card. So here we can measure it. By 19,000 it is. So here we need to in dimensions we can provide it should be 10 times. Either you have to scale it down. Now we can do accordingly whatever here. But normally what you have to do means we should scale the total things down to like 1 meter. Below 1 meter means it will be easy for, otherwise it will be very difficult to do some meshings, that's all. So normal card is like 19,000, so it should be 10 times. 10 times means then this vertical directions everywhere it should be equal. A minimum 10 times or like at least 10 times that length should be. And here it is 5 times. So for 5 times it will be like 90, sorry, 5,000. Normally we need to scale it down, otherwise it will be difficult. While I'm importing that lines, the coordinates, it was like in meter, so that's why it took this much. And here also two type of mesh we can do. One is one if you want to go for structured mesh means we need to go the we need to make control volume accordingly. Or if you want to make unstructured means in different control volume, so accordingly we have to make. So for doing that, if I'm going for structured mesh means what I have to do means first now I made the control volume, so I can create uh, surface from sketches. Select this sketch and give apply. So surface is created, and then next thing is to boolean, because we want to have only the external flow. So for external flow, here boolean target body and the tool body. So you will get the shape, exact shape. If you are importing points, you can see exactly how the shape will say similar shape you will get. But that 3D curve option, sometimes it will create that surface accordingly. So sometimes the shape will be there will be some deviation in the shape. So now the shape is created. Now, if I want to go for structured type mesh means, then we should split the faces, or else one method is there. There we can go for structured plus the unstructured, but it will take time. For meshing itself, it will take time. But other things, analysis parts and all, solution parts and all, it will do the same time. It will take same time only. So for now, I will teach you how to do the structural analysis. So structural analysis part, structured grid. Sorry, for a structured grid part, we need to again split the control volume. So for splitting the control volume, we need to draw lines. So I'm drawing line. Before that, what I'm doing is I'm creating one more sketch here, selecting the plane, creating one more sketch. Otherwise, this sketch will be merged with the sketch one. So it will be like again in Ansys, again we need to do everything. So what I'm doing, I'm drawing one line from here to this and one more line. Now I'm giving dimensions from the axis. Now we got the dimensions, but we should check if the dimension is at 25% of the card. So the total card we have is 19,000. So into 0.25, like 4,750. So 4750. And here next one is like at the exactly at the trailing edge of the card. So 19,000 I have given. Now we got two lines, and one more line we need to draw from, so that this area also it will get splitted up. So I'm drawing one more line. Here also we should check whether this line is drawn properly. So I'm giving dimensions. I'm giving 19,000. So now a line is drawn, and now I am going to split the faces. So for splitting the faces, in tools face split option is there. So in face split option, what you have to do, select the target face first, then select the lines, give generator. Now you can check by selecting the face filter. So 1 2 3 4. Now one more mistake I did. Like again, this region also I need to split in the form of faces. So I am drawing again, selecting this thing, making one more line. Now again I am giving face split option. Select the face, splitting this by means of this line, selecting the line. So give generator. Now again check one. So total faces should be like 1, 2, 3, 4, 5, and 6. Now we can go for meshing. So one more thing we have to do, we need to make this line because we imported in the form of points, we need to merge all points. So after doing this, we can easily merge. So you can see here one single line will be there. So while doing this will be connected to this arc. Same way, this side it will be connected to this one. Otherwise, if more number of edges are there, means I cannot give this um, this meshing and all. It will not be proper, and we will face difficulty in giving the element sizes and all. Then again, this two regions is there that I need to merge. So better ways like importing your model in some modeling software. That means airfoil in some modeling software. Then if you are bringing here, whatever dimensions you want to do, same thing will be imported, and lines will be like a single line. So no need to do these things and all. Now still, since I have imported our. So once again, give generate and close. Now drag and put the meshing. See here, physics preference again CFD we have to give. Once that is done, then can see here in meshing, right click, insert sizing. So edges first. I'm selecting 1, 2, 3, 4, 5, 6, 7. Total 7 edges. So you can see here that it will be divided into some number of edges, some numbers, some values which is given. So I am giving like there are two options. One is element size. We can mesh the total thing by element size also, or else we can go with number of divisions also. Now I am going with the number of divisions. I am dividing this line by 100. I am giving means so it will be divided into 100 divisions. If I am giving 150 means it will be divided into 150 divisions. So here biasing, first one you select. So you can now see give 100. It is not very clear here. Now you can check how it is getting after we have to define the biasing factor. Right now I am giving like 1000. If I am giving means see, you can see here the region which is very closer to the airfoil is getting biased well. That means refined well. So this is a refinement. So you can see the refinement here. If I am increasing the bias, depend upon our conditions, we can change that also. So here the top two edges are like near to the airfoil. It is we are having fine mesh, but other all things is in opposite manner. So we need to give reverse bias there. So there select the edges which is to be reversed. 1, 2, 3, 4 and 5. Total 5 edges. So now you can see all the edges are like is showing refinement from the near to the wall. Then next thing again edge sizing, give sizing 1, 2 and 3. So here also give number of divisions, you can give 200. So it will be divided by 200. Here also you have to give biasing. So in biasing we need to define how much. Same I am giving 1000 only. So now everything is in opposite direction. We can change here also. So now you can see this region is like a highly refined other regions because that will be near to the wake region, not required. So this also we did. Now next thing is like we need to mesh the regions which is the airfoil and also the region at the that C type domain. So that we need to do. So for that again edge sizing. In edge sizing select this one 1, 2, 3 and 4. So here, if I want to increase it again, means this region will be increased mesh. You can see the structured mesh which is formed, and the region which I want to see this region near to the wall, how the mesh is. It is very fine. If I want to increase, also we can increase, and this region also, if I want to increase that to like 200, if I want to give 300 means you can see the difference in mesh afterwards. Can see the difference. Now if I want to increase this again means, or else we need to decrease the front region to match the mesh. Here at the leading edge region, I have given fine meshes. That means two of this two edges alone, 200 I have given. If I'm giving 100 means, like this only we need to do. We should correct our mesh. We should make our mesh a little bit proper for getting some high quality grid sizes. So this also, if I want this one, we can increase it further for refining, but not required. Right now we will do with this only. Now once the meshing is done, check the meshing is done, then your next job is to give the naming. Naming can be given in two regions, either in the geometry or else in the meshing. Afterwards we cannot give the naming. So I'm giving naming here. This will be the inlet region, and this is outlet, and this will be our airfoil. And other regions are wall or far field we can give. I'm giving wall only. So now check the names: inlet, outlet, airfoil, wall. So all namings were given. Then once again give generator and close it. Now once this is done, next is the fluent. Drag and put fluent onto the mesh and give update. So once it is updated, always give 4 core, because depend upon your computer, this will also change and the performance will be affected. So better is to give 4 core. So now if you are doing any compressibility analysis means, we should go with the density based. For other things we can go with pressure based only. So here in models, give the energy on SST K omega, or else you can go for a Spallet Alamas also. For airfoil, Spallet Alamas Almaris is enough, but still, if you want to do any turbulence, I want to study any turbulence means, then you should go for Spallet Alamas only. And here, certain conditions like Sutherland, viscosity Sutherland, that will be the basic you will be studying in CFD, those things. And here inlet, we can give the velocities. Right now, we will give one normal speed. So I'm giving one 30 meter per second. Give apply. Then outlet region, it should be pressure outlet, and other conditions remain same. So I'm not changing that. Then compute from inlet or to the surface body. Here, if 3D case means, here certain things will change. For 2D case, no need to check the things. Whatever we are giving at the boundary conditions, it will be updated. And scheme will be like either I can give symbol or else this coupled also, it's okay. Better give symbol, and pressure is standard. For high-end conditions, if you want to do any turbulence, here third order also it is there available. Mostly we will do second order conditions only. Then monitors, you can define reports by report definition also, or else you can do by this one, report plots. So here you can give like post and select the air file, print to console. Okay, similar way, new lift, select the air file, give lift, print to console. Okay, now next is like residuals we can give. Normally what we will do, we will do everything in 10 power minus 5. Now for our case initial study and all, this is enough. So standard initialization, compute from inlet and give initialize. Once initialization is done, do the calculation. I'm giving 500 and give calculator. So you can see the plots here for airfoil. This is how your airfoil analysis will look like. Once the pressure distribution around an airfoil will look like this only. So here for velocity, you can change that to velocity and get the results. So did you understand everything? What I did? I think it was little bit faster. But you can get the lift and drag values from straight away from this only, fluent only. But the results will be clear if you are doing here. Okay. Suppose I want to do check the streamlines means a streamline also we can check. So so this is how your streamlines will look like. This can be increased. This number of points can be increased to have a closer look at the near to the surfaces. Okay. And if you want to plot any line or CP and all, you can plot straight away in Fluent only. That also I will show. And for saving, you can see here this camera picture. There you can save the image with whatever background, and the screen size also you can change by using this one. So white background means your image will look like, I will show one image. This is your airfoil analysis. You can get images in like this with the white background also. Suppose if you want to plot the CP, here also we can plot, but here again it will be like somewhat difficult, but in Fluent means easily we can plot. See from results, XY plot is there. Here y-axis pressure, in that which one, static pressure or pressure coefficient, and we should select the surface where the pressure coefficient to be plotted. And if I give, you will get the clear airfoil, that means the CPO or around the airfoil. And if you want to write that to file means, click here, write to file, it will get righted. So that suppose I want to save in desktop means we can give that one, so it will be saved in desktop only. Give a name, it will get saved, then you can go and check. See, this is the CP value which you got over the surface. Then this can be taken to some other plotting software for plotting. So this is how we need to do the CFD analysis over a 2D file. And if you are giving the conditions everything perfect, now I have given randomly. But if you want to give perfectly, you should study which airfoil you want to do analysis, what type of airfoil, and what Reynolds number you want to do. Accordingly, you can give. Okay, this is how you have to do the CFD analysis. If you have any doubt, means you can ask.
So thank you, Jimmy. Student, if you have any questions, so please ask. Student, you have any doubt in this session? Let's
I
just move
think they don't have any doubt.
forward.
But no problem. You just practice this one. You will get an idea. Once you are familiar, you can do other analysis also. Okay. So, ma'am, so anyone, any doubt means you can ask. Once again, I'm repeating, or else
Yeah,
if
there is one question came up in the chat box
yes,
that how can we plot this lift and drag?
lift and drag automatic. See, lift and drag. we will get values in the console itself. We will get the values, but once the values we got, that is for one particular airfoil. Okay, here we will get see. I think it is closed, but you can if it is closed also no problem. You will get the values. We should save somewhere first. Right, first we need to save it, and the case and data file will be there. There, if you go inside, you will get the lift and drag plot saved in one file. From there, you can take, or else you have to run once again. Then for a different angle of attack, again, if you are doing like this, means you can see here, I can duplicate this one. Easily we can duplicate. Once it is duplicated means you can give namings also. Like 3 degree I'm giving means for 3 degree angle of attack, what will be the lift we will get. For 0 degree, what is the lift we got? And now for 3 degree, like that, for some 5 or 6 angle of attacks you have to take. And the similar way, you will get some CL value and also CD value. Then go here, take one Excel file, angle of attack, then 0, 3, 6. I'm giving randomly some numbers, 12, 15. Suppose we are doing analysis like this for 15 angle of attacks, sorry, 5 angle of attacks, 0, 3, 6, 9. Then we will get some CL values. CL values in the form like 0 0.2, 0 0.4, like that we will get some values. Then you can plot. This is how you will get. If here it is getting stalled means see, you will get the CL value. This is the CL curve. Like this only you have to plot. No other way. In Ansys, you will get only for one angle of attack. For if you are doing some n number of analysis with the different angle of attacks and different the angle of attack, you will easily can get the values. Okay. Anything else, ma'am?
Um, so there is one question, like, is it okay to share your email ID, Jenny?
I can share. Ma'am, you only share. You have my email ID, right?
Yeah, yeah, just asking because there is our one student, Ivan, so he's just asking. Okay.
Okay.
There is another question, how we can change the angle of attack for an airfoil in the CFD itself.
Angle of attack. Okay. That I will show. See here, boundary condition is there. Inlet. Okay. In inlet, here x component, y component is there. In x component of flow, you have to give cos. Suppose 3 degree I want to change means cos 3 degree. Cos 3 degree have some value. That value you have to put here. Same way. 1 second, I will show. So cos 3 degree, we will get values like 0.99886. And for sine 3 degree, 0.05233. So this value apply, close. And better is to do with coupled only, because Ansys some default things were there that will be working well. and do the same analysis. Okay. Once it is initialized, whenever you are changing, you have to initialize. Then only it will take the values what you changed. Otherwise, it will not take the values what you changed. Then sometimes some random numbers will get. So in this way, you can do the things. Okay. Any other doubt?
Student, you have any other further question? I think you are showing the value that
Values of this is values of lift and drag, ma'am.
is showing.
And here one problem is there. Normally, lift and drag. I imported the airfoil like some. It is more than it will recognize in meter. So 1 meter airfoil means okay. Our airfoil is like 19,000 meter. It was too much.
19,000.
Yes,
Okay,
sir. That initially I didn't corrected that values and all. So
okay, okay, okay.
it was in different, like, sorry,
Unit.
19 meter or some higher meter it was there. So that's why here the values are wrong. It's
Okay.
not wrong.
But
Values
it
which
is
is not
also that
selected
yeah,
will be like
boundary condition you have given.
0.17. Huh? What, ma'am?
As per the boundary condition you have given,
Yes.
velocity is also very low.
Yes,
No?
velocity is low, but CL value we will get whatever we are giving. CL value will be like it will be same only. Whatever
Yes.
is prescribed, it will be coming in that way only. This we need to correct it. Like it will be like 0.117 for this zero angle of attack. For this particular airfoil, we are getting 0.117. So like that we have to correct it. Other all things correct only.
Yeah. One more, I think students has faced this issue. Like, what if the solution is not getting converged? Like, can they further, proceed?
Uh,
What is
Actually, minimum generally in industry and all, they will do 10,000 iterations and all. But it is not possible for us to do 10,000 iterations. So at
yeah,
least
those things
minimum,
are complicated. Yeah.
yes, it will become complicated. So my suggestion is like at least 1,000 iteration you have to give.
Okay.
Minimum 1,000 you have to give. And for normal airfoil and all, it will normally it will get converged.
Okay.
Maybe because of some what to say, sometimes
Maintenance
some
cycles error.
conditions are wrong. Based upon that, sometimes it will show some error. If anything apart from that, any errors there means I can send me the screenshots whenever I'm free. I will that mistakes and all I can correct it.
Right. Okay. 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 Fine. So, well, give them some task for next session. So at least they will get practice. Apart from,
Ma'am,
of course,
easy,
they will be doing
one
that.
easy task is there. That are tools only. For a particular airfoil, CL curve and all is there. Suppose 0012,
Yeah.
4412, 2412. That airfoil CLCD curve will be there.
Yeah.
So do
A difference
analysis
Reynolds
of the
number.
same airfoil with the same Reynolds number and find the answers for that.
Yeah.
We should get the same curve.
Yes.
Small error is okay, but too much error is like so you should bring accordingly. The error should be minimum. Almost we need to get the same curve. Is that okay? That will be the assignment for this week.
Yes. Yes. Yes.
Go for some two airfoils, one symmetrical and one unsymmetrical.
Yeah.
And one
Different
more
tools
thing,
also
ma'am,
they are doing.
better is to import airfoil in some modeling software, and
Ah.
after importing there, create surface there.
Mm-hmm.
Once surface is created, ask them to save us IGS file. Then easy to import here. Here, what happens? We will use some. Sometimes it will not work out. That's why. Huh?
Yes. 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 Because some of
Or-
the tail will the trailing part won't be there. So
yes.
we need to create it manually.
And that we can create it in airfile tools. Here only we can create, ma'am.
Yes.
Trailing edge, close the trailing edge. If you give,
Closing the
will
trailing
show.
edge.
Close trailing edge. If you give, automatically the trailing edge is closed. Okay, then send to airfoil plotter. Here you can give like how much you want. If I am giving some 100 means automatically that will be open.
Right.
So once it is there, give plot a CSV file. We will get the CSV file here. This can be imported in any modeling software. It's fine.
It can be imported.
Yes.
Yeah.
This we have to save as TXT file. So depend upon the software. Some softwares have like we need to use XY coordinates. Some we need to use XYZ coordinates. So if Z coordinates means, and again one more zero we need to add everywhere, then it will be like then we can import it.
Right.
So IGS file is there means easy for doing analysis here. Then only Boolean, do the Boolean, make control volume, do the Boolean, and we can start the analysis.
Right. Okay.
Let them
Still
no,
you
no,
have
first
any other
let them
question?
start.
Yeah. Yeah.
Uh,
Right. Right.
After that, we can mold them.
So, all right then, that's all for today. If they have further questions, so they will just drop a mail to you, or they will get back to us, and then maybe in the next section as well. Right?
Okay, ma'am. Okay.
Yeah. All right.
Thank you.
Thank you, Jenny. Thank you for
Thank you.
today's session. Yeah. Thank you, everyone. Good night, everyone.